So, welcome to the walkthrough from Comprehensive Maths. It's now, as you can see, November 2017 entry for Edexcel Higher, and it is paper 3, third and final one. So keep your calcs out there ready. Although it's not much use for question 1. So only worth 1 mark. It wants the median. So technically, it's halfway between the 40th and the 41st. So it's only worth 1 mark, so you could list it all, but I'll just add it up as I go along. 4 plus 11, so up to the 15th, up to the 39th in that group, so it must be in the 4th group down. A terrible one there, but I'll live. It's in the 4th group down. When you draw a frequency polygon, you use the midpoints, don't forget. Slap down the middle. It's cumulative frequency that uses the upper limits, the upper class boundaries. So do make sure you plot the correct heights, the frequencies at the midpoints. So 135, 145, and so on. Number 2, one of them typical here, you've got a calculator. Let's do some conversions. Loads of ways of doing it. You can start with London, take it all the way through to New York, start with New York, take it all the way back to London. I've done the method of taking it halfway down in each. So I began to look at New York. So in New York, 1 US gallon, straight away, 3.785 litres costs, so is equal to $2.83. So I find the cost of 1 litre. That's always my preference. Go for the unitary method, find the cost of 1. So you divide both sides by 3.785, giving me cost of 1 litre in New York, $0.74. I went a bit further, just in case it's quite close. It turns out it's nowhere near close. On we go. I started London and do exactly the same. Let's find the cost of 1 litre in dollars in London. So in London, we already know that 1 litre is £1.08. So £1.08. Yeah, there's a 9 on the end. Who cares for now? And then we want to convert it. We've got the litres. Let's convert it to dollars. All right, we've got pounds. To go from pounds to dollars, that's a multiplier of 1.46. So we're still getting a litre of petrol, but by multiplying that by 1.46, we're getting $1.58 and some other numbers. So as you can see, it's not even close. Now, common sense will tell us, in America, they don't tax as much. There's a low tax economy. So we knew it wasn't going to be close, but we had to show it. You must show you're working. So New York is the cheapest. It's actually cheapest by half, isn't it? It's better than even half the price of London. It was hoping you'd multiply when you should have divided and vice versa. But yeah, the answers are actually miles apart. Number 3, here's the key to be careful. Kilograms, grams. So yeah, make a note of that. You want the volume, cover it up. So we do need to do mass divided by density. But the mass, because it wants the answer in centimetres cubed, and we've got grams per centimetres cubed, easiest thing to do is get rid of the kilograms and say that the mass is 12,500 divided by the density. It wants 3 sig figs. Answer is 647.66. So we go to 648. Number 4, good old linked ratios, nice and straightforward in my opinion. But as always with these, it could be a lot worse. Get your answer organised. There are only B, G and R pens. B to G is 2 to 5. G to R is 4 to 1. Why have I left a gap? Because that's where your link is. The link is go for 20 for green. So that's multiplied by 4. That's multiplied by 5. So as you can see, when we've got 20 green, we've got 8 blue, 5 red. In other words, that's 33 pens if they're in that connected value. But we've got to be greatest number below 100. So 33 goes to 66. But actually, we need to go for 99 pens. So everything gets trebled. So how many red pens are there? 5 trebled gives us 15. Number 5, reciprocal. You may know it as flip or whatever, but don't forget, for your calculator work, it does mean 1 divided by. So your answer will probably give you that as a fraction. Press your SD button for 0.625. Error intervals, so number in the middle, and it's always less than or equal to for the lower limit, because on the upper limit there is the potential to write recurring and so on, but I wouldn't bother. So when it's rounded to 1 dp, which in this case is nearest 10 pence, you've got that amount. So up by 5 pence, down by 5 pence. And like I said, that upper limit, if you've been taught to go for recurring, 9.849 recurring, fine. Personally, why bother? Number 6, clever little question this. At the end of the day, you've got to link them. So if that's, whatever that is 7 centimetres longer. Now, when you look at this shape, it's not quite 4 of everything. Here's the thing. If I put a little notch on here, we've got 1x plus 7, 1 of them. We've got 2 of them. We've got 3 of them and 4 of them. So we've got 4 lots of x and 4 lots of 7. Now, what about the other side? Well, if you look here, I'll mark it with a cross. That is an x. So is that. So is that. And so is that. So there are 4 of them. But that's not everything. Do notice there's a couple of sides not accounted for. How long are they? Well, that's the length of the rectangle minus the width of the rectangle. In other words, 7. Because it's x plus 7, take away the x. So there's an extra 14 on the end, and we're told it's equal to 70. So let's simplify the x's. Let's start with 70. We take away 28, and we take away 14. And to find x, we divide by 8, or halve it, halve it, halve it. X is 3.5, but don't pat yourself on the back just yet, because that's not the question. You need x, but it does say work out the area of this shape. So the area of that shape, it's 4 lots of the area of one rectangle. A rectangle which has a width of 3.5 and a length of 3.5 plus 7, 10.5. On your calc, you should be getting 147. On we go. So number 7 is one of them where stick it in your calc exactly as you see it, type it all in, hit the equal sign. My calc gave me 7.452. times 10 to the power of -4, which obviously is in standard form. Answer as an ordinary number. So don't forget, a minus power means a small number. And we need to move the decimal point 4 times. That gives us 307452. Just double check. 1, 2, 3, 4 times. Nice little question. Good revision for standard form. Number 8, our old friend wordy stuff. Don't overcomplicate. Don't waffle too much. Whose results are best? It's Mel. Why? Because she's got the highest number of trials. So more reliability, more data equals more reliability. Question B, use all the results. So if you add up the top row, they got point down 100 times, and they got point up 50 times. So the probability that it lands up the first time, so it's 50 out of 150, in other words, a third, times by pointing down. Pointing down is 100 out of 150. The 150 doesn't reduce because nothing's been taken out. All right, it's not one of them where we're picking counters out of a bag or whatever. That's also 2/3, so it can be done on a non-calc this. All right, because that's 1/3, that's 2/3. Top times top, bottom times bottom, 2/9 for your answer. Number 9. So one of them with a bit of trial and error, like trial and improvement, I think is the best way. Pick some values for n is the key. So at the end of how many years? So the original value, all right, the current value, 50%, half it is 6,250 equals the original value times 0.85 to a certain number. And if you divide both sides by 12,500, you get a half. Now, if you've seen any A-level or got someone older who does A-level and ask them how to do it, they'd use logs to find this. We won't, we can't. Well, you can if you know how to use them, but let's not bother. Pick a value of n. I did n equals 4. 0.85 to the power of 4 gave me roughly 0.52. In other words, 52%. Not quite below 50. So you know what's coming. When you try 5, I got 0.44. So there we go. It's in the 5th year. Question B, not related at all. It's still percentages. It's still about Jack, but it's not related. So at the end of the year, so Jack pays 40%. So that's the key. Don't fall into the trap. That means he keeps percent, and that percent has a value of £79.20. So we want 100%, because that will tell us how much interest he got in total. So best way to go from there to there, in my opinion, divide by 6, that gives you 10%, and multiply by 10. And if you do the same on the right-hand side, take that amount, divide it by 6, times it by 10, you get a nice £132. So that's the interest Jack got. Use it. So the idea is work out the percentage rate. Well, he got £132 out of the 5,500 he invested. And if you times that by 100, I've rounded it off cents, we get 2.4. That's it, 2.4%. is Jack's interest rate. Number 10, good old probability. Waffle, waffle, waffle. You add up what you've got, you get 0.95. So you do 1 minus 0.95. So red is a 20th. That's a great 5, isn't it? What is the least possible number of counters in the bag? Well, it's all based on red. The fact is, it is possible to get a red, so there must be at least one red counter in the bag. So that's your starting point. The fewest red counters must be 1. Well, the probability of getting a red is 1 out of 20. That is 0.005 as a fraction. And if red is 1 out of 20, there's got to be 20 counters. That's the smallest you can be. Any smaller than that, you can't have a probability of a 20th. On we go. My usual slight cheat for number 11 for drawing lines on, but it is what it is. So A, median means middle. Draw a line from 30, go across and down. I got 57. Mark scheme usually allows 1 square either way. Then we've got Jamil saying that the range is 40. Is he correct? Well, he could be correct, but not necessarily. Don't forget the principle that when you plot cumulative frequency, you use the upper class boundaries. So that means there are 60 up to and including 80 grams. But the final one could have been 75 grams. And the smallest, if you take it down the other way, the smallest is just in that group. There are 2, because that's where the graph starts. There are 2 weights in that group. They could both be 39, 38, 30, or whatever. But at the end of the day, is Jamil correct? I'd put no, he may be incorrect, as the max and min. The max could be below 80 and the min could be below 40. I won't turn on to the next page because all it asks you is show that less than 25% of the potatoes have a weight greater than 65. So you find 65 grams, up you go and along. As you can see, I'm hitting 49. So in terms of greater than, that's the above. I'm saying that out of these potatoes, 11 of them are above. So 11 potatoes out of the 60 potatoes, times it by 100 to get a percentage, and I get 18.3 recurring percent. As we can tell, it's obviously less than 25. That's all you need. Don't overcomplicate, don't waffle. Number 12, Alan and his spinners. Alan, greatest name ever. So, read all that waffle, but the one thing that really makes a difference is the penultimate sentence down here. Both spinners, red is 24. Because that's the key. Work out an estimate of the number of times we get white. Well, we'd really like to know how many times Alan has done this experiment. So, to get 24, if you let x be the number of trials, don't have to write that, the fact is that however many times he's done the trials, times by the 0.25, times by the 0.6, he got 24 red. So that's, get on your calc, find the number of trials, 24 divided by 0.25 and 0.6, you get the reassuringly nice round answer of 160 trials. We haven't finished yet. He does the experiment 160 times, so he'd go down that route, times it by 0.75, and wherever your answer is, times it by 0.4, and that tells you how many times. It tells you an estimate for how many times, and we get 48. A nice answer that makes sense, so you can be reassured you've nailed it. Number 13, they come up all the time. It's bog standard, complete the square. So you just get into automatic mode, halve the number next to x, square it and take it away. Don't forget about the -7. And simplify. -7, -9, take away 7. We go down to -16. Number 14, I mention it pretty much every paper because there's always a scale factor question. Now, I'll rub this out in a sec, but let's not forget, in a straight line, if you double the length of a straight line, you times it by 2. If you double area of a shape, if you double the length and double the height, you're getting times 4, or in other words, 2 squared. And for cubes, same principle, but that's the key. To go from linear scale factor to area scale factor, you square it, and you would cube it, and you would square root and cube root accordingly. So let's take it back now we've reminded ourselves of that fact. So it's giving you a ratio of volume. So to go from 27 to 8, what's the multiplier? The multiplier is always divide by what you've got, multiply by what you need. That's the multiplier for volume. But we want linear. Linear scale factor is 2/3. Cube root the top, cube root the bottom. But now you've got the linear scale factor, it goes on to surface area. So we want the area scale factor. You must square it. So the area scale factor is a multiplier of 4/9 when you go from cone A to cone B. We've got the surface area of cone A, so we multiply it, and we get, as you can see, it's a show question. We hope we get 132. Calculator confirms it. Nice. Number 15, show the equation. Now, I'm only going to remind you of how to go about this. Like a lot of these things, I've given the full, exactly what you should write in an exam. The full way of doing this question is on my worked answers. So go to the Edexcel Higher page and check it out. It's under worked answers. All you do is sub in the 0 and you get -5. Sub in the 1, you get +3. Because they are either side of 0, you have to state change of sign, negative to positive, and it's what we call a continuous function. Okay, it's not a reciprocal graph where you might have a break. It's a cubic graph, so we know the shape of it. And if you're going to go on to A-level maths, very popular question on domains and ranges here. So, but it is a case of there is a change of sign and a continuous function. Hence, a solution must lie between 0 and 1. And what I've just regurgitated to you is the A-level way of writing that. Try and get as close to that as you can for GCSE. Great practice. Part B. So notice there's no square root, cube root, or any nonsense like that. So no square rooting or cube rooting. So I'm going to add 5 to both sides. I'm going to subtract. No, I'm not. I've just looked at the answer. Sorry, folks. I'm going to factorise an x out. That's where that x squared came from. Should really look at my, because I have done this paper already and I uploaded it for worked answers. Should really look at it now and again, shouldn't I? X squared plus 7. And you're there, because now you just divide by the brackets. Part C, again, I've written it out in full on the worked answers. Don't get put off by all this terminology nonsense. At the end of the day, use your ANS button on your calculator. So to get the next term, sub 1 in to there. So on your calc, do 5 divided by 1 squared plus 7. You'll get a nice number, 5/8. Your next number won't be as nice. To get your next number, stick it back in. So on your calc, I would keep the 5/8 in your screen. Now press 5 divided by bracket, ANS squared plus 7, close bracket. My calc gives 320 over 473. You could write it as a decimal if you want, but who cares, because you're going to keep that in your calculator screen. And again, to get the third and final term, you're going to use the ANS button. Same again. 5 divided by bracket opened, ANS squared plus 7, close brackets, and we get, doesn't say how accurate it wants it, I get 0.67044, and then it goes 830, so I'll just go to 83. Easy to round off. Doesn't say how accurate you want it, but don't do 1 or 2. Go to 4 or 5, or like I've done, 7, if you want to be daft. On we go. So part D, by substituting your answer in. So don't clear your calculator, keep your answer in, press ANS cubed, because you're subbing it into here. Press ANS cubed plus 7 lots of ANS minus 5, and you get a very, very close to 0 answer of minus 0.00549. Comment on the accuracy. As you can see, it's extremely close to 0. So comment on the accuracy. It's very close to 0, so it's a very good estimate. Just leave it at that. Number 16. Errors and bounds. Waffle, waffle, waffle. Where you start working is important. This is where you start working. 148 3 sig figs. So we go up by half and down by half. Car, litres, petrol, up by an extra decimal place, sorry, and down by the same amount. Nathan says my car used less than 8 litres, so he's trying to get a low value. So we need to look for the worst case scenario, in other words, the upper bound. To get the upper bound in this formula, you want the largest amount of petrol on top, so 11.85, divided by the worst possible distance on the bottom. Worst means lowest. And if you stick that in your calc, sorry Nathan, we get 8.03 litres. So I'm afraid worst case scenario, if it goes against it, the upper bound, you could be wrong. So finish it off, it says, could Nathan be wrong? Yes, because the upper bound, it is 8.03. On we go. Reasonably standard double trigonometry. Say reasonably because they've not given you enough length, but they have given us this, the area of the triangle. So when you're given the area of a right angled triangle, we know it's equal to 1/2 times A. We'll call A 11. We'll call CD. We don't know it. That's what we're going to find out. So 1/2 AB sine C, the angle in between them. Stick all this in your calc, but you're wanting to find x. So whatever you get in your calculator, 1/2 times 11 times sine 105, you need to do 56 divided by A and S. Or if you want to work backwards, start with 56, double it, divide it by 11, divide it by sine 105. I don't care how you do it, as long as x works out to be about 10.5. Now you can move on, because what you really needed was the length of AC. I'm going to call it B, because it's opposite to B. So off we go. AC squared, because we've got one side, we've got a second side, we've got the angle between them. You find the opposite by applying the cosine rule. So I can say B squared is equal to 11 squared, doesn't matter what order, and 10.54 squared, minus 2 times B times C. Stick it in your calc, work it out as you go along, saves time later. 231.9 cos 105. Get all that in your calc and square root it. I'm getting 17.09 for my B. Take a deep breath, because what did we do all that rubbish for? Work out the length of AB. I'm going to call it little c, because it's opposite angle big C. Yes, folks, we've got the angle and an opposite side. We've got big B, that's the 118. We've got little b, that's 17-ish. It's now the sine rule. So I can say I want little c over sine of big C, that's 48, equals little b, that's my 17.09, over the sine of the angle opposite, 118. So again, you reach for the calc and you press 17.09 divided by the sine of 118, and to get C you multiply it by sine 48. Not forgetting the 1 dp. The answer I get for there is 14.385, yada yada yada. 14.4 will suffice. Great question for revision, by the way, folks. Those sort of things you revise in the area, the sine rule and the cosine rule. It's a lot of work for 5 marks, but it's great revision. Usually you don't expect all of them to come up in one question, not even all of them across a set of papers. But there you go. As you can see, folks, if you hate trigonometry, revise it, because the worst case scenario is they can all come up. On to number 18. I slightly disagree with the number here, but I'm going to go with what the mark scheme says. Estimate for the distance travelled. Distance travelled is area under. How do you find area under? It says use 4 strips equal width. So the width of every strip is 5. I want the heights of every strip. So the height of this one is 2, because it's 5 for every 10. So each square's a half. So do be careful with that. Height of that one's 5. Height of that one's 10. And the height of that one is 4 below 20. So be careful, it's 4 halves. That's actually on 18. Now again, on my worked answers, I've written out exactly as an examiner would like to see it. Here I'll just waffle through it. So the first shape is a triangle. So half base times height, a half times 2 times 5. The next three are trapezoids. So you need to add the parallel sides together. So in this case 7, halve them and multiply by 5. I get 17.5. Next, add the 5 and the 10, halve it, times by distance between them. You should get 37.5. And the final one, the biggest one, 10 plus 18, halved, but then multiply it by the 5 that's in between them, and you should get 70, and you should get the final answer of 130. A very common question here, is it under or over? Don't forget, basically folks, if it bends that way, it's always an underestimate. If it bends that way, it's always an over. And if you aren't sure, draw a diagram. I know it's exaggerated, but something like that. Is your answer under or over? It's overestimate. Because when we work out the area, we get some extra area because the lines of our shapes goes beyond where the curve is. So if you don't want to draw a picture, that's the sort of phrases you want. Number 19. Now, there was a question on paper 2 about coordinates, and because they've just left a big blank page, it's very tempting to draw a diagram. No, not at all. Prove algebraically it's a tangent. Let's not forget, a circle and a line will be a tangent if you do simultaneous equations and you only get one solution. Because if it's anywhere else, you'd get 2 solutions or no solutions. So you might say, what happens if it's down here? Well, yeah, it could be, but it'd still get one solution. It's not 2 lines. Well, we're looking at one line. And that's the key. This is a simultaneous equations question, quite hidden, but you're hoping you only get one solution. You get like a repeated root, in other words. So when you factorize it, it's going to end up like 8x plus 2 all squared or some nonsense like that. So I would simply add 2y to both sides. What am I doing? 2y plus 10, you numpty. And I'm going to sub it in. Replace x with 2y plus 10. It needs squaring, adding to y squared. And obviously it's us an algebra. Expand, simplify, and factorize, etc. Solve it if you can. So, squaring brackets, square the first, square the last, times them together is 20y, and double it. Don't forget the y squared on the end, I very nearly did. Let's put the y squareds together, let's simplify. Nothing to simplify with the 40y, but we have got 100 and take away 20, so we have got 80. This looks like a nightmare to factorize. Nope. Everything is divisible by 5. Gives you a lovely quadratic, because when you factorize this, 2 numbers that multiply to make 16 add together to make 8. Yep, it's 4 and 4. Now, obviously, that means y equals -4. You could mention that that makes x2 by subbing it back in, but they're not that interested. It says prove algebraically it's a tangent. So now's where you say something like only one point of intersection. Hence, it must be a tangent. Again, I've written it out perfectly, exactly as the examiners want on my worked answers. Speaking of which, same here. This is written out in full on my worked answers here. I'm just going to talk through it. Now, you don't need reasons specifically, but I would because it's a proof. But don't repeat yourself. It is an isosceles triangle question. That's the main thing. So I'll read out what I would write. So first thing to do, stick an extra line on. That's quite important, that. Why is that? So I am going to say that AO, OC, OB, they're all equal. They have to be equal because they are all the radius of the circle. They have to be the radius. They have to be equal. So your first statement is AO equals OC equals OB because the radii. What does that mean? Well, it means if we call this angle X, we can write these two angles down, specifically that angle there. The reason you can give, base angles of an isosceles triangle are equal. So angles in a triangle add up to 180. If you knew what X was, you'd take it away and you'd halve it. We don't know what X is, so we just have an expression. You could simplify that expression. However you do it, that's the angle ACO. There, or there if you fancy it. But now let's move on to the second triangle, the right-hand side. If that's X, that angle there, because angles on a straight line make 180, that is 180 minus X. And we repeat the process with these base angles of a triangle. Of an isosceles triangle. How do we work them out? Same process, folks. You do 180 minus this angle, in brackets by the way, that's quite important, and you would divide it by 2. Now when you take away the brackets, 180 take away 180, they're gone, and it's minus a minus X. So in other words, by just letting X be an angle and 180 minus X be the other angle, you've now got two angles that meet at C. One of them is 90 minus X over 2, and the other one is X over 2. And look at what happens. But it all simplifies to 90. So you can prove that circle theorem without any other circle theorems, because it didn't want you to say angle at the centre is 180, so you halve it. But it does show you how you can prove that circle theorem by using essentially base angles of isosceles triangles. Again, quick plug, go to my website, comprehensivemaths.com, go to the Edexcel page where you might have found a link to this. If you found the link through YouTube, go to my website. It's written out exactly like an examiner would want to see. And now we take a deep breath. This is a corker of a vectors question. Again, I've written it out in full on my worked answers. I'm just going to talk through it here. I do it totally different to the mark scheme. I hope mine makes sense of it, because here we go. So what's the waffle telling us? It tells us that that is A. It tells us that that O to B. So each of these is a half B. And the final thing it tells us is that is double. So as I say, I've done it in proper writing on my worked answers. Here I'm just going to talk you through it. So the key to it is find the vector, find the journey from M up to N. So M to N is, we go to O first, that's minus a half B. Then we go to A and double A, so we go 3A, like so. So that's one way of writing the journey M to N. But there's another way. So let's now take into account this bit here. A to P is a multiple, or in this case a fraction, of the journey A to B. So let's just think about, let's go up here. How do we write the journey A to B? So we go against A first of all, so minus A, and then we go plus B. That's the first bit that we can use to think of. Then we start thinking, well, what do we do if we want to go from here, from M to P? How do we go from M to P? That's the tricky bit. Well, the easy bit is we go against the half B, and then we go with the A. So that's all easy, but now comes the difficult bit. We go from A to P. A to P is a multiple of AB. But we've just done AB, so we can insert it. A multiple, that's K, and I'll just flip it round. There we go. Now, here's where my technique is massively different. I'm just going to mention the diagram before I get rid of it. My logic is this. So we know how we get from M to P. We're told that's a straight line. So whatever M to P is, if we multiply the whole shebang by an unknown number, we should get how we get from M to N. And that's exactly what I do. So let's just go through it. If we take M to P, which is A minus a half B, added to K lots of B minus A, times by a number I don't know, fraction of some descript, that multiplier turns it into MN. Now you might say, why is that helpful, Al? Because you've just brought in an extra letter. Well, it's because one of the concepts that I've mentioned on one of my other papers, I forget which, you can now do something called, because when vectors intersect, when they cross, it means the A's equal the A's and the B's equal the B's. So in other words, let's try and pick it out with a different colour. I can say that whatever is next to A, so there's a 1 in there, in here, sorry, there's a 1C by the way, because the C is times by everything. Then, what is next to A here? Well, there's a minus, there's a K, and there's a C times everything. So I've got C minus CK. That's what's in front of the A's on the left-hand side. What's in front of the A's on the right-hand side? 3. Now let's look at the B's. Same principle, should have changed colour to. In fact, let's just, because that's really what I was doing. Let's get a green involved. So let's just look at the B's. What is next to B on this left-hand side? We've got -1/2, but we've also got should be timed by C, and we've got a KC as well. This CK or KC is also the coefficient in front of the B. On the right-hand side, we've got -1/2. Now, it might not look like it, but these are dead easy to solve. Why? Let's go back to purple. We started in purple, we'll finish in purple. Come on, technology. Notice the -CK, the plus CK. Add them together, they will disappear. So 1 plus -1/2, I have a half C. They disappear. 3 plus -1/2 is 2.5. In other words, 5/2. So I get my value that C equals 5. Bad news, it did want K. Well, pick one of these equations. Let's pick the top. Let's rewrite it, but this time replace the C with 5. So we get 5 minus 5k equals the 3 on the right-hand side. We subtract 5 from both sides, and we divide both sides by -5. So -2 divided by -5 is positive 0.4. Or in other words, 2/5. And if you just check the diagram, 2/5 makes a perfectly reasonable answer. What a chuffing question that is. As I say, I've done it a totally different way to the mark scheme. I might do a video I have got on the YouTube channel. I've got about 4 or 5 vectors questions done and dusted so far. I think I'll add this to my list and I'll do it an alternative way just to show. I'm not sure the alternative's any better, by the way. I've just gone for a very different concept there. I hope it made sense. It's a corker of a question, it really is. Anyway, there we go. That's that paper done. I'll see you on the next.